Hello my friends, welcome to Code Guide channel. This is video about how to implement the deep first search algorithm. The goal of this swap is to write a DFS function that takes a graph showing us adjacency matrix and starting node and return all nodes you can reach from it. The main idea is pretty simple. Instead of visiting all the neighbors, first we go as deep as possible along the path and then backtrack when there is no more nodes to visit. To implement this behavior, we will use a stack. To implement this type of behavior, we will use a stack and the last in, first out principle. Let's get started. User story number 1, you should have a function named DFS. The function should take two arguments, adjacency matrix and a node. A second parameter, node, is supposed to be a number between 0 and n-1. For example, we have adjacency matrix. The length of this matrix is 4. It means, according our formula n-1, the possible nodes labels are 0, 1, 2, and 3. It took a while for me to understand what they mean, that's why I'm explaining it. The first argument tells us what graph we are searching, and the second tells us where to start. Let's define first variable stack and assign it to the list. In this list, we will put the start point, our node to visit. I also define the second variable called visited and assign it to the list of false values, multiplying by length of adjacency matrix. It gives me the total numbers of nodes in the graph. Let's return visited and print it in the console. I just need a good example. Each position corresponds to one node. At the beginning, all values are false because we haven't visited any nodes yet. Next, I will create an empty list called result. This is where I'm going to store the nodes that our function actually visits. The main part of the algorithm will start from the while stack. We will keep running the loop as long as there is nodes in the stack. Inside the loop, I remove the last node from the stack. Checked node equals stack pop. As you remember, the pop method removes and returns the last element of the list. Because we are using the list as a stack, this gives us the last in, first out behavior. Next, I check wherever the node has already been visited. If not visited, check node. If visited check node is false, then not false becomes true, so we enter if statement. Let's assign visited check node to true. This way we will mark node as visited. Next, we need to add the node to the result. Result append checked node. Now I need to look for all the neighbors of the current node. For neighbor in range length adjacency matrix check node, where adjacency matrix check node gives me the row where we are looking for our current node. So we are iterating through the row. Then I check wherever the current node is actually connected to the neighbor. If adjacency matrix check node, neighbor equals 1. As you probably remember, if we have 1, it means there is an edge between two nodes. If there is an edge, then we need to append the neighbor to the stack. As you see, we don't visit the neighbor immediately. We put it into the stack so that it can be processed on the next iteration of the loop. And because this is a stack, the most recent added neighbor will be processed first. And of course, we return the result. That's it, we are done. The source code will be available in the description below. Thank you for watching. See you next time. Bye bye.